Perfect. The next step is to, of course, create an instance of this class, which will be an object representing exactly that naive Bayes model. And so there we go. We're going to call this, as usual, classifier in order to be coherent with the next sections of this implementation, and mostly so that we don't have to change anything, right? Because then we call this classifier variable to predict the results and visualize the results. So there we go, classifier here, and then equals, and then we're going to call this Gaussian NB class in order to create indeed this naive Bayes model. Okay, perfect. And now you know how to finish this. We need to take our classifier again, from which we're going to call the fit method, which will train this classifier on the training set composed of indeed X train and Y train, right? I hope you did it even faster than me, because indeed this is exactly the same as before. And now you are also independent and know how to find the information you need in the API. Okay, great. So once again, there we go. That implementation is over. And we're ready to get the final results, and mostly we're ready to find out if we can beat the record accuracy, of 93%. So I can't wait to see, so let's do it right now. Let's click this folder button to upload the dataset, right? We have to do it in order to train indeed that naive Bayes model on the training set. So right now, your notebook is connecting to a runtime to enable file browsing. And once again, in a second, we should get the upload button. There we go. So we're going to click it. And here we are in the kernel SVM folder. So let me show you the path once again. Please find your whole machine learning A to Z folder, which you could download in the previous tutorial, if not already. And then inside, we're going to go to part 3 classification. Then section 18, we're making good progress here. Naive Bayes. Then Python, and then social network ads.csv. Okay, we press OK here. We have the dataset, all good. And now we can run everything in order to get indeed our new results. So let's do this, run all. And now all the cells are running, and especially this one, there we go. We now have our Gaussian naive Bayes model. And well, let's see the results one by one, starting with this one. So that's the prediction of a single result, that first customer of the test set of age 30 and estimated salary $87,000. And remember, in the Y test, the real outcome was 0, meaning that this customer didn't buy the SUV. And that's the prediction, which is indeed the correct prediction. And then when predicting the test set results, well, once again, we see that we have a lot of correct predictions. All this is correct. All this is correct. This is our first incorrect prediction. Another one here. And then another one here, all correct, another one here. Oh, I'm not sure we're going to beat actually that accuracy. We seem to have more than 7 incorrect predictions at first sight. Not sure, but let's see. Well, that's exactly what we're about to find out right now. So are you ready? The question is, will we beat the accuracy of 93%, which was the best accuracy resulting from both KNN and kernel SVM? And so let's see what we get with naive Bayes. And no, unfortunately, we don't beat the record. Indeed, the accuracy we get with that naive Bayes model is 90%, which beats indeed logistic regression, but does equally the same as the classic SVM model with a linear kernel. All right, but still, I think we will get nice visualization results. So that's the code cell where we visualize the training set results. And well, this time we got the results pretty fast. You can see that the cell is already executed. So let's see. I can show you that indeed the naive Bayes curve is pretty nice, right? It is a nice smooth curve, right? That catches well indeed these green customers here, the ones who in reality bought the SUV in the right green region. But unfortunately, it separated the two classes, with these two prediction regions a bit large, not very precisely. And that's why we don't get an accuracy that is higher than 93%. But still, we made a progress with respect to logistic regression, because indeed remember that for logistic regression, these green customers here could not be well classified, right? Because of this straight line, they fall in the red region. And here in our naive Bayes implementation, well, these green customers fall in the right region. So at least it corrected that. But since here there is kind of a large margin, well, these green customers which were correctly classified with the kernel SVM, if you remember, right? These are the training set results. right? So I'm talking about these ones. Here they are correctly classified, except these two and the third one, but clearly with naive Bayes, well, they fall into the wrong region. Okay, but anyway, at least you see the prediction curve of the naive Bayes model, and mostly you see that the naive Bayes model is clearly a nonlinear classifier. And you know, in some other situations, because the naive Bayes is causing less overfitting, well, in some situations it will do better than your other models. So that's why it's always very important to try all of them. And remember, at the end of this part, I will actually deploy all our models with new simplified code templates for each model, you know, without all the prints and everything, in order to deploy them in a flashlight so that we can quickly figure out what is the best classification model for any dataset, you know, regardless of the number of features.